Okay, it's 2 o'clock, so we are going to start. And first of all, you need to go to the menti.com and check the QR code or enter the code. And okay, if you have a question, just send me a question. Yeah, I like the hearts. The students are still coming, so I have to press the admit button. So just wait. Okay, let's go to the YSAC. And this morning, I uploaded a new competition. So in the notice section, you will see the Kaggle competition, 2 out of 3. This is going to be our second competition. And the URL is very similar. I just made the dates. So let me copy and go to a new tab. And the title is Financial Engineering Competition. And a little bit information about this new competition is a 2-step regression. So the first competition is about the simple regression. So you have all the data, and all you have to do is predict column 5 using all the other variables. But here, the goal in this competition is still to predict the column 5. But if you look at the data set, and there is one more missing column. So column 3 is not in the test set. Of course, the data set is different from the first one, but the basic structures are very similar to each other. So if you cannot solve the first problem, you cannot solve the second problem. So let's go back to the first, our competition, and see what was going on. And then we are going to move to the second competition. So let me go back to our first competition. So now I see a lot more students. So we have altogether 115 students here. And there are already a lot of submissions for get a better score, but still the interrank one, it's 타락 파워 전사. I don't know yet who this guy is, but okay, so you already know the basics of the competition. So let me go back to the data set. In the first competition, so there are basically 3 data sets. The first one is train, the second one is test, the third one is submission. So train is, it contains all the columns, including the target columns. So based on the training data set, we are going to make a TensorFlow model in order to predict column 5. And then once you have your trained model, then you use your trained model for test.csv. And the test.csv does not have column 5. So the job you have to do is to predict that missing or the hidden column 5. And then using the predicted value, you need to make a submission file and then submit to the competition. And your score will be calculated immediately. And then based on your score, you will be ranked from top to bottom. And the score here is the mean, it's root mean squared error. It's basically a mean squared error. So your task is to minimize the prediction error as much as possible. And then just take the root of them is the value here. So let me go back to the data section and take a look at each data file. So submission.csv, it has only 2 columns. The first column is ID column. So you may think that this is the problem number here. It's so 2, 10, 13. And then column 5 is the result you will submit. And in this example submission file, every number is 0.01. So this is just the baseline. And then if you look at the train.csv, the train.csv has 8 columns. The first column is ID, but this ID doesn't, okay, let me tell you how can I make this data set. So first I make a data set from with index, with ID 1 to say 70,000. I don't remember the exact number. And there is some specific rule. So basically there is some special relationship between all the column values. And then I divide it into 2 pieces. The first piece is the train.csv you are looking at. And then the rest of that is actually the test.csv. And of course, at the first, the train.csv and test.csv, they all contain the column 5. But in order to make this is a competition, I delete the column 5 in test data set. So if you see the test data set, it does not have column 5. And that the missing column 5 is actually in the competition in the solutions. So whenever you submit your submission will be compared to that exact solution to calculate the mean squared error of your submission. Okay, okay, I have a question from you. Sure, yeah. I will talk about the new competition again and again. So yeah, for your understanding, I would use the whiteboard. So I'm explaining how I make the data set. So at the beginning, the whole data set is something looks like this. It has ID and column 1 up to 7. and then it's 1, 2, 3, and up to some number. And actually, yeah, these 7 numbers are related in some way so that you can, there is some function, but I will not let you know what that function is. And then I divide it into this data set into 2 pieces. The first one is train.csv. The second one is test.csv. Of course, the selection is quite random. So anyway, yeah, it has say 1, 2, 3, maybe 1, 3, 5, 10, or something. And the second one is there is no intersections, so it's 2 because there is no 2, and it's 4 and 6, 7, 8, 9, and so on. And in the train data set, it has a column 5. But I take the column 5 out of the test data set and then put it in the answer. So this is the answer. And this is the answer. So your job is to make a model using all these values and then apply your model to test data set and then get the submission result. And that is the first competition. The second competition is very similar to this, but I made a new data set for the second competition. So it's competition 2 out of 3. So there is a new data set. And I also divided into 2. So one is train, the other one is test. And then train has all the data set, but for the data set, there are 2 missing columns. So column 5 is missing, and also column 3 is missing. But your job is still to make the prediction on column 5. So how can you do that? The first very naive approach is you just take out the column 3 and just ignore this part, and then using your TensorFlow model for train without the columns 7, and then use your model to take the test data set to predict column 5. Then that will be a very bad, that will result in a very bad submission because you just ignore the 1 column. So the better way is to first you need to make a prediction on column 3 and then use that predicted column 3 to predict column 5. So that's why I call this competition as 2-step regression. So you have to do it twice, but you have to do it very wisely. So this is the second competition, and it is going to be a little bit more difficult than the first one. Okay. Okay, basically you have to submit only the answer file about column 5. And you don't have to do all the necessary steps because your score will be calculated based on your submission of column 5. But yeah, so actually, yeah, if you really approach this problem very naively, then you just ignore the column 3, and then I'm gonna predict the column 5. And that's okay. But in that case, your prediction will result in a very bad result, because you just ignore the one given information. Okay, and instead of going all the details again and again, I prefer to wait your question so that you can practice some more. And then if you have any problems or any questions why we have to do that, uh, or what is that lines of code means, then I will answer to that kind of questions. Use of column 5 to predict 5 is bad, but which is better? I did not say that. What I'm going to say is this one. In the second competition, we have 1, 2, 3, 4, 5, 6, and 7. This is train data set, but in your test data set, there is only 1, 2, 4, 6, and 7 columns. And your task is to predict column 5 with these 5 columns. So the first approach, which I said, naive, is just you also ignore the column 3. And then since there is a 1, 2, 4, 6, 7, and here is 1, 2, 4, 6, 7, and this 5 is a target. So you can train your model based on this data set without column 3, and then apply that model to the test set to get column 5. And this will result in a bad result because you just ignore the one column. So the better approach that I believe is that first try to predict column 3 using only the other 5. And since your trained data set all the information that is needed to calculate, to train your model, so you can train your model to calculate the column 3 first. And then once you finish your regression, then you can use all of them to predict column 5. And I think, that would be that will result in the better solutions. So that's what I'm trying to say. So why I said this is the second two-step regression. So first, you need to make a regression to predict column 3 first, and then using that column, you are going to predict column 5. And I will do that, but not today, because I prefer to take your questions instead of showing all the code you need, so that you can build your own model and try to learn something So yeah, so I will do that, yeah, in the end, but in the end of this semester, but I will not do that yet today. Competition 3, I guess I will upload it in 2 weeks. So uh, so today I don't have much to say. So I just wait to see how you are doing, and then next week the same thing. So we are going to talk about the TensorFlow, the the uh, re-explanation of the competitions, and then 2 weeks later I will. So let me see the calendar. So today is uh, today is here. So I'm going to upload the on 20th, the third competition. I will go through the competition to code almost at the end of this semester. So there is no explicit explanation for the competition 2 and for the competition 3. In that way, you are uh, trying to do it by yourself. Okay, so let's start with our first competition, code. So let's go back to our first competition code. And now you may ask, uh, if you can understand any part of this notebook, then you may ask to uh, explain what is going on, but be specific. So not saying that just go from top to bottom, and that's too tedious. So I'm just waiting for your questions. Okay. Let me read what's going on here. Okay, I'm gonna go into the edit version. So in first cell, we are just reading the file names in the directory. So there are 3: submission, test, train, and we import the TensorFlow libraries. Okay, Okay. Uh, since I don't see your code, maybe I can let you share your screen. So I think, yeah, there is a. Okay, now you can share your screen. So yeah, try to find how to, yeah, share your screen so that I can see your code. Then I will read your code and then uh, answer your questions. And actually, I can make it share. The share is possible for all students. So if you wanted to see, if you have specific questions on your code, anyone can, yeah, share your code, yeah, right now. So why don't you share your code? Maybe I can stop my sharing first. Stop sharing. Does any volunteer who wanted to show your screen? Yeah, I'm waiting. Yeah. Hmm. There is no one who is willing to share code. Okay. So we import the TensorFlow and then read the file and check whether there is a missing value. And I think, yeah, I should refer to the TensorFlow. And since there is no missing values, yeah, we can just, yeah, split. Uh, our data set into train data set and test data set. And then we make the separation between features and labels. And then since we don't need ID, uh, we make it top. And then I'm going to show you, yeah, some interesting information. So in the TensorFlow, there was another import, Seaborn as SNS. And once you have that, you can make a plot. So it's SNS pair plot and train data set and some data columns. But since we have the data set column not in this name, we have to change it to say column 1, 1, 2, and so on. So I'm going to make a copy and paste something. So I think, yeah, I need 7, 1, 2, 3, 4, 5, 6, and 7. And then it calculates the pairwise plot. And at first, it does not show you the result, but if you collapse, if you press this button, you can see. Oh, yeah, okay, yeah. So basically, this is the okay. Let me read the horizontal one first. So it's column 1 to up to column 7. And on the vertical axis, there is also column 1 to column 7. So how can we read this graph? So the first one is actually column 1 on the horizontal axis is column 1 and the vertical axis is column 1. So it is just the distribution of the column 1. And it has, yeah, some values. And then the second plot is column 1 versus column 2. You can see here, column 1 versus column 2. So column 1 is somehow, yeah, correlated to the column 2. And the third one, column 1 is correlated, it's a column 1 versus column 3 and 4, 5, 6, and 7. And as you can see, for some of them, there is no correlation at all. But for some of them, there are very strong correlations. So it might help you to understand the problem. But even if you don't know what's going on here, you can still use this Keras model. So I'm going to show you what is the meaning of the normalization. For the normalization, it says train data set. This is our data set, the train data set, and then describe gives you lots of different statistics, and then it make it transpose. So let me type train data set describe, describe. Then it gives you the information about the each column. But for some reason, I want to make it to be transposed. So this is the data set, describe, and transpose, and I just wanted to see the mean and the standard deviation. So this is the mean. This column is mean, and this column is standard deviation. And normalization means that column one, the whole number structure of the column one is quite different from the column three and column four. We can make it to somewhere around the zero and with some unit variance. That's the meaning of the normalization. So in order to do normalization, the TensorFlow offers the normalization layer. So it's pre-processing the normalization. So it just make a normalization layer. And then the second line of code is apply adapt method to normalizer. And how can this normalization be adapted? So using our train features. So that's the meaning of these normalization layers. And then print some values. So it says first, we define a normalization layer and then provide some information on each column. And then this normalization layer calculates the mean and variance of each column. So if we see the print, the first column has it's 1.06 to the power of 2. That means exactly this number. And then for the second column, it's 105 and it's 105. So it has all means and variances, but I just printed out to the mean only. And this one is 5.5, but it's exponential negative 2, so it's 0.055 something. And then I think I have some more questions. Yeah, that's the topic we are going to talk over and over again. But I cannot say just the one thing that, okay, if you change this one, your production get better. I cannot say that because there might be lots of different ways to improve your predictions. So that's why I'm explaining the normalization first, because there are lots of different topics and I want you to ask me something, but you guys didn't ask me anything. So I just choose the topic that one student suggests and talk about the normalization. Yeah, for this kind of problems, you have to wait because there are lots of other students who already know how to do that. So for students this kind of questions have to remain at the end of the class. And I will stop. I will finish today's class very earlier than usual. So you just wait by the end of the class, and then you can ask me the yeah, how can we submit this kind of things? So I will answer that. And it does not guarantee. Yeah, normalization affects the output. That's absolute, but I'm not sure whether it has a positive effect or a negative effect. So why do we take the normalization? So that's the main reason I'm talking the one topic at one by one, because normalization is a very popular technique in user machine learning, but there is no guarantee that normalization improves your performance. So we have to try it. Okay, yeah, you're right. Normalization makes the numbers similar to each other, but when you print it out, the number stays the same. Yeah, that's right. Because this layer, the normalization layer, is not applied to the data set yet. So we just define the normalization layer. And then what I'm going to show you from now on is to apply that our data to normalization layer so that we can have a normalized value. So, okay, I instead of copy and paste, I'm gonna write, type everything. So let's first make a variable named first, and it's a MP array, train features up to 1. So what is that? It's our first number. So this is the our first row data set. And then we are going to apply our normalization layer to this one. So normalizer. You see, they are different. So I'm gonna make a print of the first and print normalizer dot numpy. So the first one is the original data set, and the second one is the normalized one. And let's think about it why this is true, because the first number is 140, 140. But since the mean of the first column is 106, so 140 minus 106 divided by 57 is the actual this number. So let me show you. Let me show you. I'm true. So I'm gonna make a copy because I cannot remember these numbers. So just make it here, and then it's 140 minus Control V, this number, and divided by this number. And actually, I have to make it a comment. So you see, this number is exactly the same as this one. Maybe you may not agree with that, because the later digits are different, but since all these numbers are just the not not in the full precision, because here, yeah, we do not know the last digit, so this is enough. So I think, yeah, this is I did answer it. For competition one, if you change the epoch to say 10,000, would that improve the result substantially, or would the improvement the result become trivial after certain epochs? So how can we know that? We have to experiment it, whether it can improve it or it just stays at the same level. So yeah, just, yeah, wait a second. Yeah. So this is the normalization layer. And how can we use our normalization layer in this model? So it has, so first note that all of this is actually a function. So maybe I can, yeah, skip this function and show you directly how can we make a Keras function. So maybe I can say it's a, so let me say this is my model. And then it's Keras sequential. And inside this sequential function, I have to write down the each layer that I wanted to use. So maybe the first layer that I wanted to use is the normalization. Not because I put it as normalizer, it's normalizer. And say layers, dense, and we can specify the number of node in this one. So for simplicity, so I just, yeah, say 1. Okay, yeah, I can say, yeah, 10, and activation is relu, and I can make another layer, and another layer, and another layer. And actually it depends on you how much how many layers you want. So you may say, okay, I want it to have 100 here, and I want to have 20 and 10 and say 100 again. And then the important thing is the last layer, because this is the regression problem, you just need to have one output. So the last layer should be 1. So last layers dot dense is 1. And this is my model. And then I just, yeah, copy the compile. So let me compile. But since I named my model as my model, I have to change it to my model. So my model compile with loss function is mean absolute error. But if I want, I can change it to mean squared error. And there is no error, so it's okay. And then I can see the shape of my model by typing summary. So this is my model. So I have the normalization layer and a dense layer with 10 node, dense layer with 100 node, and so on, so on. And finally, I have just one node. And then I need to fit. So I'm going to make a copy of this one and put it here. And again, I have to change the name of my my model because I named it my model as my underscore model. So in order to use a fit, I need to use the my underscore model dot fit, and then epoch is just 10 for quick response. Maybe it will take a couple of minutes. So let's just wait. Oh, okay, it's done. And now I can make a graph using the matplotlib, which is located at the end. So I can add the graph and then plot loss and history. I don't know how to do it. Plot loss history. Yeah, it's much better. Well, let me see. I changed the measure to mean squared error. So maybe that's the reason. Okay, for comparison, I'm gonna change it back to the mean absolute error. Mean absolute error. And then try to fit again and try to plot again. And it'll take some time. Oh, okay. Actually, this is not that good. It's still 0.025. Okay, so making some more is not so substantial, and making normalization in this case it's not so successful. So okay, for this question I can answer. So you have to increase your number of epochs and then watch the graph. So if your graph is still decreasing, then you can increase the number of epochs. But at some point in time, your graph will stay at the same level, and then you may stop at that point. So that's the way we decide. I decide whether I should increase the number of epochs or I just stop here. No, your understanding is not correct because just think about in this way. At the end, you have to solve the problem given in test.csv. And test.csv does not have column 3 and it does not have column 5. So if your model is to trying to column 5 to predict column 3, then your test data set does not have column 5, you will be fail. So that's the problem. Why did I show normalization layer? That's because in some case, the normalization layer makes your prediction much, much better. But in this case, I cannot see that much improvement, but normalization is a very common technique to improve the accuracy or the to reduce the prediction error. So that's the reason why I show you the normalization layer. Okay, okay, I will explain, but I want to see how many different questions I have here. Yeah, this is still competition 1, and the node that I'm using is already shared. And if you feel it's too fast, that's okay. You can ask me later again and again and again. So that's why I'm going to be a little bit lazy at this point of time. So I'm not going to all the way to the end of the topic. So I just explain one thing, and there is another question. Then I will repeat that. I will repeatedly respond to your questions. So it's okay. Yeah, it's you may ask it something later. How did I choose the number of layers? Is it just random? Yeah, basically, there is no such a rule to guarantee that what is the best solutions. So one thing you can do is maybe you can try to make everything is equal, say 10, 10, 10, 10, and then maybe you can increase the number of node as you go down, or maybe you can decrease the number of node as you move down and see which one works better. So that's the old kind of experimentation. Or in some case, you might reduce the number of node and then again make it increased. And there's those specific rules. So actually, there are lots of things you can experiment in order to improve, but there is no specific rule. And that's you may feel that uh, it's too hard, but that's the usual situation in a new field. Because the machine learning is quite new, and there is no such a rule, established rule. So all we can do is to make lots of experimentation and then get some insight from those experimentations. And normalization is such a result. So at the beginning of the machine learning, some people used the normalization and some people didn't. And they just realized that whenever you use the normalization, it's not as bad as the original one. So that's why we use normalizations. Oh yeah, I can reshare this my notebook, but as you can see, my notebook is now, I cannot follow the usual order, so it might be messed up. So yeah, but I will, yeah, reshare. Okay, when you change the split to zero point 0.9, it's fluctuated a lot. Uh, and actually, that fluctuation really depends on the number of epochs. And since we are doing we are doing the number of epochs as 10, it's very okay to fluctuate very rapidly. But as you increase the number of epochs, your graph will uh, uh, gradually approach to some minimum levels, but it will take a lots of times. All three competitions will be counted. Yeah, there are students not from this class because it is a competition. The total number of students will be about 270. But our class, my class right now, the intro to QRM, we have 107 students. But yeah, I'm going to make a grade out of the 107 in QRM course. And then, so you don't have to worry about the other rank other than in this class. Uh, if it is not finished yet, then there might be a problem. So in that case, yeah, just stop it and then change your program to this one, the verbosity. Here, okay, we know how to control the number of epochs. And the one thing here is verbose is one is uh, it prints out a lot of things. So let me show you. So you can see all the result because, and then it will do 10 times, but you can see the progress. So if you cannot see this progress, then your program is something wrong. And I just realized that the students who change the split to zero point 0.9 get a lot of fluctuation. And I think, yeah, I thought, yeah, your question was the splitting into the test data set and the validation, the test data set and train data set. But uh, I thought, yeah, you are talking about this one. And if you increase, yeah, this one, then your graph will fluctuate, yeah, much more. And there is a reason. And I will show you. Okay. And then, yeah, you can see a lot of fluctuation here. And that means it is not trained, which means you take the 90%. So the validation split means you may be confused, but first, yeah, we have a trained data set and we divide it into the real trained data set and test data set. And that real trained data set is here, train features and train labels. And then we again divide it into train and validation. And the validation split of 0.9 means you take the uh, 90% of your data set as the validation data set. So that means you just use the 10% of your training data in here. So since your data set is too small, it cannot be trained enough. So at the beginning, we usually set the validation split as zero point 0.2 or zero point 0.3, so 20% or 30% or even 10%, and then increase the number of epochs. Yeah, it's a regression. Yeah, and some more study on YouTube for better accuracy. Yeah, that's good. Yeah. Uh, no, actually, the DNN code was so let's go back to the TensorFlow. And in the TensorFlow tutorial, actually use the normalization layer in their model. But when I copied it from the TensorFlow, I just removed the last time I removed the normalizations. But today I wanted to explain the normalization layer, so I just add the normalization layers. And after that code, you need to figure out, yeah, you should try to figure out, yeah, what's going on at each code. Okay, activation function again. So ReLU is a very fancy name, but actually this is nothing but this one. So we have a layer, and within the layer, we have node, and we are going to have some values from those node. And we are going to apply this function to each node, max 0, and the value from here. So why do we use this ReLU function? And the reason is simply we wanted to have non-linearity in our model. So remember that regression is basically start from linear regression, but linear combination of linear function is still linear, but there are lots of problems who possess a non-linear structures in the problem. So in order to incorporate the non-linearity, we use this max function. Then the max function graph looks like this. So this is the one way we incorporate non-linearity. And there are still other activation functions, so-called softmax or 10H. And at the beginning of the machine learning stage, many people believe that the softmax function or 10H function is much better than the other things. But recently, we realized that the ReLU is almost always the answer. That's the the simple rule why we have to use the ReLU. But of course, if you want to use the softmax or 10H in your model, that's okay. You just replace the activation function name from ReLU to the softmax. It doesn't hurt you much. I think instead of having a break time, I'm gonna stop here. So I'm going to explain something more, but from now on, I'm going to explain something more fundamental. Okay, let's take a break. And then, yeah, I will announce it again. So let's take a break. Yeah, we'll be back 3:20. Okay, the fluctuating graph means the prediction is inaccurate. Yes, that means you can improve it or you are totally wrong. But usually, it's the both situations are possible because if you do not train enough, then your graph will fluctuate. But in some case, as even if you increase the number of epochs very big number, you can still get the fluctuating graph. That means your model does not predict properly. So there might be some way to improve your. So that indicates that your model is not accurate. So you should improve your model, but there is no exact way to improve your models. Okay, so to improve the fluctuating graph, okay, the first thing is that it's very simple. If you increase the number of epochs, usually your graph will converge to some level. So in a, if I draw, the x-axis is the number of epochs. And at the beginning, it will fluctuate, but if you increase the number of epochs, then you will get some stable point. The problem is we do not know the number of epochs that will be stabilized in advance. We cannot know that. So the only way we can see that is actually we increase the number of epochs. And it will take lots of time. But let's say, yeah, this is currently we have about 0.02 levels. And once you reach at the stable region, then the increasing the number of epochs does not help you at all. And in order to increase the accuracy, then you have to change your structure of your model. So basically, your model has lots of layers. And usually we say that as we increase the number of layers, we will get the better result. And as we increase the number of nodes, we will get a better result. That's just a general rule. The problem of increasing the number of epochs and number of layers and number of nodes is that it will require your lots of time and time and lots of computing resources. And the bigger problem with that is that if you really increase the everything, then at some point in your model, you will get this is your model. But as you can see, there was a validations in our graph. There was a validation line. I just take the another one. And actually, this validation line is the almost exactly same as your actual score. The reason is that your model is always trying to get a better result and better result and better result. So if you increase your number of epochs, it will go down, even if it goes down slowly. But your validation curve does not go at some point below, because that is the nature of your model. So the usual stopping point is somewhere around here. So you are looking at your model's performance, but the better the better measure is actually see your validation result, because the validation, that's the reason why we split the data into the actual train and validation. Validation. So your model is trained on trained data only. And then the validation data set tells you just, apply your model, the learned to your new data set and get the number. So actually the validation data set is not used for train. So that is a good, and the validation data, for that reason, validation data shows you the real attainable actual score, because it is not used for train. Yeah, I will help you, to get the competition too. Yeah, I can help you, but not right now, because in order to help you in competition two, I need to help you competition one first, so that you can be much comfortable with all the normalization or validation split and how to interpret the graph. So once you are comfortable with those concepts, then I can move on to the competition too. The ideal graph, well, the ideal graph, ideal. Ideal means error zero is the ideal thing. So if I draw the ideal graph, then I will say and this is for your model, and for your validation, this is the ideal graph, because you are going to be perfect. But in some sense, it is impossible. if this is possible, well, you can make it possible. If you make a really huge uh, models, then it might be possible. But with our limited time and limited resources, we cannot do that. Yep. Okay, so now let's go back to my competition. One, and the book. And I'm going to start a new notebook. So first cell is given. So we can always run the first cell without any problem. And you should see these three files. And in order to make a submission, first we need to read the submission files. So let's say df is pd read underscore csv, and then read this file. So once you read this file, there is no output because it just read your file and save it to df, and that's it. So if you want to make a real submission, you have to save your data frame to your CSV file. So before we do that, we just take a look at what's inside the DF data frame, and it has ID and column 5. And as you can see, the column 5 is all 0.01, but that's okay, yeah, because what we are trying to do for our model is to predict the column 5. But let's just say we have our prediction here. And how can I save it? df2 underscore csv, and then make the name that I'm going to save. What I'm going to save is my df, but what file name I wanted to save. So I have to specify the file name, and file name is a string, so we have to use the quotation mark. And so, and actually, you don't have to use just the submission. You can just say anything. So it's any file, but you have to save it as CSV. And then index is equal to false. False is not defined, yeah, because it should be false with capital letter. And then save your version and save and run or the second button and save, and it will save my version very quickly because I do not have anything special here. Okay, and then go show version and go to viewer, and you will see something on your output, and then press the submit button. And then you can submit your files. And the file name doesn't have to be the submission.csv. It can be anything, but I suggest you to use the CSV, and it will shows your score. And once you are done, you can see the leaderboard, and you can see your uh, scores here. So that is the minimum basic. I already said that I will not upload the recorded Zoom lecture, but if you wanted to see the recorded version of the Zoom lecture, send me an email and I will let you come to my office and you can watch the recorded Zoom lecture in my office. So that is the minimum basic. And we are going to go to viewer and edit. And I'm going to show you very quickly how you can build a TensorFlow model. So in order to make a TensorFlow model, I'm going to delete, these things. So I'm going to show you the minimum. So first you need to import the TensorFlow. So import TensorFlow as TF. And then I'm going to use the panda read CSV and file name. Oh, I don't know the file name, so it's train.csv. So this is my train data set. I'm not going to split into two parts. I just wanted to use everything. But I still need to make labels. So let's say DF AQ TURES. DF features is DF. And DF labels is DF pop column 5. And I don't need ID, so DF, I should say DF features, FEAT. DF features dot pop ID. DF features is not defined, okay? DF features is not defined. There is no column 5. There is no column 5 because I have to make a copy. Let's see, DF features is difficult. So I'm going to read DF. Yeah. Yeah, all three competitions due December 23rd. Yeah. So I had some difficulty here, and that kind of difficulty arises from whether I did it once and did it again and again. So for example, I might have some problems. And if you have some problems when you make your programs, the good way is to just reload everything. So if you see a menu here, we can say restart the session. Then restart the session does not eliminate your code. It just reboot. So here, draft session starting. And then try to run from the very beginning. So import TensorFlow again and read the data file and see what's inside, and then do something that I need. And I did not, I don't use the normalization here. I just to show you how to use the TensorFlow model. So I'm gonna make my model is TF Keras sequential. And since this is a function, we need a parenthesis. And this parenthesis will take just one input, and that one input is a list. So that's why we write a bracket here. And then the simplest model that I can think about is TF Keras layers dense. And the simplest one is just one node. And I need to specify the input shape. So input shape, here we have column 1, 2, 3, 4, 6, and 7. So we have all 6 columns. So that's why we write 6 and comma. And this is the way we write the tuple. And in order to see what's inside my model, I say my model dot summary. Then this is nothing but just a one linear model inside. But this is a model. And after that, if you want to change your model, then you can add some more layers and you can add some more node here. So that kind of things. But here, I'm going to make it really simple. And then my model dot, I need to provide some information. So I'm going to say compile. Compile. And then the loss is, say, MSE, mean squared error. And my optimizer equals, say, Adam. So that is the minimum way to specify our compilation. And then my model dot fit. And then you need to provide your X data, Y data, and the number of epochs. That is the minimum. So my X is df underscore features, and my Y is df labels, labels, and epochs is say 10. Then it will calculate the loss. And you can see at the first epoch, the loss was 60 and 1, and it's getting lower. And it's all done. And once we train our model, then in order to use our model, of course, this model is really terrible, but in order to use our model, I have to read my test data set. So I'm going to read PD read underscore CSV and my test data set. And the name of my test data set is this one. So I'm going to copy and paste it. And to see what's inside, it has column 1, 2, 3, 4, and 6 and 7. And we don't need the ID. So test pop ID. Then my ID is gone and I can see my test without ID column. But I can use this test data set to predict my values. So my prediction is my model dot predict. The test prediction. And I can see my prediction here. So this is my prediction. So once I trained my model and make a prediction, then I'm going to save it to my submission file. So the way we can make our submission file is first, we read the submission file. So my answer file will be pd read csv v. So this is answer file. And in the answer file, we have a column 5. So I'm going to replace the column 5 with my prediction. So it's answer column 5 is equal to prediction. Is it prediction or predictions? Yeah, prediction. And then my answer file has a value. So I'm going to save it to CSV and to a new name. So it's answer.csv. And then index is false. So once I've done that, I can save and run all. And once it is done, go to the view and go to the output. And there is a submit button. So I press the submit button and then submit and view my submission. And I got my score. So this is the bare minimum structure of the our competition. And actually, I can make it in just one cell. So maybe I can. Okay, so everything is in just one cell. So in the first cell, we see what's inside our directory. And then I'm going to make some. So oh, we import our TensorFlow and then read the train data set and then do some necessary step to manipulate our to manipulate the columns. So which one is the x and which one is the y, and then make a TensorFlow model, and then it shows you the summary, and then compile and fit. Then your model is trained, and then once your model is trained, then use the test data set to make a prediction, and then read the submission file and replace the column 5 with your prediction and save it to a CSV file. And that's it. So if you do a similar thing for the competition 2, yeah, you can do a very similar thing. But in order to do the competition 2, you should be able to uh, understand everything here. And this is all we have done in this semester. It's about 20 lines of code. And in order to understand what these 20 lines of code are doing, we have spent quite a lot of time. And I think it's almost time for you to get the big picture of what the machine learning is. And I hope you can make some good understanding and make better questions about the specific things about all these code. And I think I have a question. Do I get better score if my code is simpler? No, not at all. the uh, the scoring system does not see your code. It only see your final CSV files. So it doesn't matter whether your code is simpler or not, but it's always better to make your uh, program as readable as possible. Because right now you may think that you can understand all of this your code, but maybe 2 days later you you may not understand what is going on. So make lots of comment on the uh, on your code. So this is why I did. Otherwise, you may not remember what you have done. If there's no output part on the go on the viewer, my code something wrong. Uh, in order to get the output part, you have to press the save and you have to press the save version. Then you will always get the output section once you press the save button. But there is a if something is wrong, then there might be nothing on the output section. But you should have the output menu here. So I said, yeah, you may not have the output widget, but you should have output menu. 7, 6, and 7th line. Uh, so you are talking about the how to make a model here. Yeah. Uh, but I think yeah, it's almost 4 o'clock. So why don't you ask me this question next week so that I can fully explain what this sequential means, because the sequential model is the simplest form of the TensorFlow so that we can use very easily. But in order to use the in competition 2, you should know the another form of modeling, so-called the functional model, and it has more than 2 inputs and it does not have sequential structures. So at that time, I think that's the good time to explain the difference between the sequential model and the functional API model. So why don't you ask me next week? Oh, it's not just for the second competition. You should create your own code for the first competition and second competition and third competitions. So all your competition is creating your own code to get accurate predictions. And actually, we did not talk about the second competition in much more detail. So don't worry about the first 20 minutes you missed. Oh, okay. Okay. Okay, I think that's enough for today. And if you have some more questions, leave it in the do not leave so that I can answer some more fundamental questions. But I'm not go into more detailed explanation of the code, so you may feel free to go and see you next week.
Thank you, Professor.
Thank you. Okay, thank you. Thank you. And actually, this is a good chance to ask me some more uh, fundamental questions. How can I submit my Kaggle competitions, or how can I make a Kaggle account? Okay, the submission. Okay, so in order to make a submission, first you have to participate in the competition. So the competition URL for the first one, the first competition, this is the competition URL. And since this is my competition, I don't have the participate button here, but you have to have some sort of a participation button here. And once you accept the rules and conditions of this competition, then you can go to your notebook. And then first you need to make your new notebook. But since I already have some notebooks here, so once you have your notebooks, it will be very similar to this one. So you can do something on here. I'm gonna delete all of this. So the first cell is automatic. So you don't have to do anything on the first cell. It just to show you 3 file names. And then you have to do, you have to make your own code. But to make a submission, all you need to do is actually the last two, not three, because you just read the submission file and then save it. And this is not enough to make a submission, because in order to submit, you have to save your versions. So once you press the right on the save version button, there are two version types. So one is quick save, the other one is save and run all. And you should choose the second one. and then save. Then it will automatically save all your code and then rerun your code and make output files for you. So yeah, wait for this step. And once it is done, yeah, you can see this one, but after some period of time, yeah, it will disappear. But still, you can access your saved version by pressing numbers here. So press the number, and it just show you your code and the output. But on the right-hand side here, you have the Go to Viewer button. So press the Go to Viewer button. Then on the right, you have notebook, input, output, and some menus. So go to the output menu. Then in the output menu, there will be a file that you have saved. And then press the submit button. And then the following is same, press submit, submit, submit. So basically, in order to make a submission, you have something in your output file. And in order to have something on your output file, you have to save it to CSV and index is equal to false. And that's that's the way you submit. So submit and submit and view your submission. And since I'm the host of this competition, I cannot see my score, but once you are successful on your submission, you should see your name and your score, your rank on this submission, on this leaderboard. That's it.